Hello and welcome guys to my latest video, and in today's video we will be covering about A-level CIE, the vectors chapter. So we will be covering about vectors. Okay, so since this is quite of a huge chapter, there will be another video for this chapter. And in this video, I will be discussing three of the main, topics in this chapter, which is what is a position vector, and a unit vector, and how to form an equation of a line for a vector. Okay, so without further ado, let's discuss and get to know about vectors. So for the first thing, I want you to imagine as if, as you can notice here, there's this two-dimensional plane over here, okay, that I've drawn out over here. And I want you to imagine as if vectors are something like coordinates. And I'm pretty sure that you're familiar with what coordinates are. Now, for example, if you can see you here based on the plane I've drawn, can you maybe tell me what is the coordinates of A? So if you did it correctly, you would say the coordinates are 2, 2. Same thing goes for point B here. What would be the coordinates? So it would be -2 and 0. And for point C over here, it would be 4 and 5. Okay, that's pretty easy, right? So that brings us to the idea of what a position vector is. Well, a position vector is essentially the displacement from the origin. Now, if you can see here, we have an origin O over here. And the position vector is essentially the displacement from the origin. Okay, and let's say for point A over here. So if you can see our coordinates, it's 2 units from the in the x-axis and 2 units in the y-axis. Now, so what's the big deal with vectors? How do we present this information in vectors? So a positional vector is basically like a coordinate, but in a vector form. So if you were to state the positional vector for point A, you would do it like this. So you would write OA is equal to 2i plus 2j. Now, you might have a lot of questions to your mind right now. So I'm going to explain them I'm just going to explain them right now so you can understand what I'm trying to do here. So OA over here, well, you could try to think of this 2 letters as the starting point, and this is the finishing point. So for this vector over here, we are starting from O and ending at A. So this is our vector essentially. And the big thing about positional is that it always starts from O. So no matter what, if you want to find a positional vector B, it has to be OB. Okay, so starting point is O, ending point is B. Okay, same thing goes for C. It should be OC. Okay, and okay, so that's covered. And the next 2 things over here are the most important things. So if you're pretty aware, like for example, in this Cartesian plane over here, we have X and Y. And the thing is, if you could see over here, I've written 2i plus 2j. So I is a unit which we use to represent the x-axis, and j is used to represent the y-axis. So in this So if you look at this equation, the way you'd read this is 2 units in the x direction and 2 units in the y direction. So that's how you are going to go about vectors. Okay, so this is just a simple form of how it's written. Okay, and there is another way to write down this positional vector, or normally for vectors, which is OA will be equal to column 2, 2. So normally the first row would indicate in the x-axis, second would indicate in the y-axis. So this is another easier way to write it out. Okay, so that's basically it. And why don't you give it a try? Why not you try to find the positional vector for point B and point C. Now you can pause the video to try it, but I'm going to continue. Okay, so to find the positional vector for B, as usual, positional vectors start from the origin and end at point B. So this is how you write it. Okay, and as you can see over here, it's -2 units from the x-axis and 0 units in the y-axis. So in a way, I could write it as -2i plus 0j. However, whenever you have a 0 as a component, you can often just neglect it. So you could just only write -2i, okay, which I'm just going to erase it over here. So that's it, -2i, which reads out -2 units in the x direction. Okay, and our last one we have OC. So for OC, as you can see here, it's 4 units in the x direction and 5 units in the y direction. So how are we going to write that? Let me erase this again. So positional vector starts with O, ends with a C, with the arrow on top, and it's 4 units from the x, from 4 units in the x direction. So we're going to write 4i plus and 5 units in the y direction, which is going to be 5j. And sorry, I forgot to mention a little something. Normally, if you would write in this form, you would normally add this little squiggly line below each letters. Okay? So you make sure, don't forget to add the squiggly line. Okay, and another thing I forgot. Based on my knowledge, you can write the squiggly lines, but it is optional to not write it too. However, most of the times I do prefer to write it. Okay, and let's represent this OB in the column form. So this would be -2, 0, and this would give us 4, 5. So let me just repeat myself again. So I think it is optional to write the squiggly lines down here. So you can write it if you want, but most of the times I do write it. And this is the other form, which is the column form. Okay? Alright, so that's basically our positional vectors. So just to summarize, positional vectors are the vectors of a point from the origin. Okay? Alright, so the second thing we're going to talk about today is unit vectors. So what are unit vectors? So unit vectors are vectors with a magnitude or length of 1. So what is this trying to say here? So this is essentially saying that it's a vector with a magnitude of 1. Okay, let me try to give you an example so you can understand this better. So let's come up here again, and we have OA, right? Okay, OA. Alright, OA, and we know that its vector, positional vector, is 2i and 2j. 2i plus 2j. Okay, now to find the unit vector of this, all you have to do is find the magnitude of this vector. So as we know, vectors are displacements, and these displacements have magnitudes. So how far is point A from O? So normally magnitudes are written in this form with the modulus brackets around it, and the way to do it is just simply Pythagoras theorem, where you just add up these two and square it over, which would give us 2 cert 2. So a unit vector would be written like this. You'd start with the cone on top, the arrow OA. Okay? I think this should be the right way, yeah. Or normally what we can do is we can substitute OA with a different letter, but give me a second. Normally we can write unit vectors in a form like this. So what we can do is we can substitute OA with a smaller letter like A or something, or B. So we can write it as A hat, okay, equals to, so it's basically the unit vector, the vector divide the direction. And we can nicely divide this into two parts for the x and y axis. And we would be getting 1 over cert 2i plus 1 over cert 2j, which would give us cert 2 over 2i. If we rationalize it, we can leave it as that, and cert 2 over 2j. And this is our unit vector. So the formula, I hope I didn't make it confusing, but the formula would be vector over magnitude. And this here is the magnitude. So basically just square and just use Pythagoras theorem and just divide it over the vector. Okay, so this would be our unit vector. Okay, give me a second. Squared. And if you want to test it out, you can actually try to find the magnitude of this, where you'd end up getting a 1. So that's the definition of unit vector. So if you try to find the magnitude of this, you would get cert 2 squared plus cert 2 squared. You would end up getting a 1. So that's a unit vector. Okay? And now finally the last part, which is equation of the line. So as we know over here, now for example, we were talking about OA just now. So we know it has a displacement, right? And we can actually illustrate that displacement in the form of a line. Like for example, OA. So how do we form an equation of a line? Well, equation of a line is normally represented in this form, where L is equal to R is basically a parametric form. So this is how it normally, let's say line OA is equal to R equals to the position vector, which is 2 plus, we cannot do that. I'm sorry. For equation of line is the line between 2 points. Sorry, I hope I didn't make this confusing, but it's the line between 2 points. For example, a line connecting A and C. So line connecting A and C. So normally it would be line AC, or let me just write the equation of line. The line would be R is equal to position vector of any point on that line, and a constant of your choice, which could be lambda or mu or any point, and this will be the direction vector. Now, how do you find the direction vector? Direction vector is basically AC. So our starting point should be A, final point should be C. So how do we do that? It should be AO plus OC. And as far as you know, AO is the opposite direction of negative OA. So we're going to write OC minus OA. So just minus the positional vectors, as we know, which is 4, 5 minus 2, 2, which gives us 2, 3. So this is our direction vector. This direction vector is this line over here. And to complete this, line OA is essentially R is equal to a position vector in that line. We can take point A or point C, whichever we like. I'm going to take point C, 4, 5, plus lambda, any constant of your choice, 2, 3. So this is how you do the equation of a line. Okay, so normally you take any position vector of your choice on the line and a direction vector. Well, the first step would usually be finding the direction vector, and secondly, to form the equation of the line. Equation by putting in whatever position vector you like. So that's it about part 1, guys. It's a pretty short video on vectors. I will update you guys on the second part in the next video. Thank you guys for watching. See you.